In chapter 1.1, we'll be looking at graphs. So to start, let's take a look at points and ordered pairs. So one way to visualize numbers is going to be to plot them as points on a graph. And the graph that we're going to be using is called the rectangular coordinate system, or you can call it the Cartesian coordinate system, or the XY plane. So it's going to consist of the horizontal axis, which is called the x-axis, and the vertical axis, which is the y-axis. So it looks like exactly what's labeled right here. So you can see that the horizontal portion is the x's, the vertical portion is the y's. So the more right we go, the more positive the x's get. The more left, the more negative the x's get. The further down we go, that's negative y, and the further up we go, that's positive y. So each point on this rectangular coordinate system is going to correspond to an ordered pair of real numbers, which we denote with parentheses, and it's x comma y. So the x coordinate is going to be the first number in the ordered pair, which is the horizontal distance from the origin. The y coordinate is going to be the second number in the ordered pair, which is the vertical distance from the origin, and then the origin is going to be the coordinate 0, 0. So that's an x coordinate of 0, a y coordinate of 0. It's where the axes meet in the middle. Okay, so when we have two lines, two axes, the x and y axes naturally overlap each other like this, it creates four different quadrants. So quadrant one is going to be right here. That's going to be when the x's are positive and the y's are positive. Quadrant 2, we're actually going to be going counterclockwise. So quadrant 2 is right here. And that's going to be when the x's are negative and the y's are positive. Quadrant 3 is going to be right down here. That's going to be negative x and negative y. Lastly, quadrant 4 is in the bottom right hand corner. That's going to be positive x and negative y. Okay, so make sure you just know those four quadrants by name. So let's do an example where we are plotting some points here. So we have these x, y, these ordered pairs. We have a, b, c, d, e, and f. So for point A, that's going to be negative 3, comma 5. So that's going to be to the left 3 and up 5. So that's going to be right here. So this is point A. Point B is 2, comma negative 4. So x is 2, y is negative 4. So right 2, down 4. That's B. Point C is going to be 6, comma 0. So it has an x coordinate of 6 and then a y coordinate of 0. So it's going to be on the x-axis. For D, negative 4, negative 3, to the left 4, down 3. It's going to put us right here. For E, 0, comma 4, so x equals 0, y equals 4, so that's just going to be up here on the y-axis. That's going to be E. And for F, 0, comma 0, that's the origin, so that's right there. Okay, so that's just some examples with plotting those points. So let's extend that the use of the rectangular coordinate system, the xy plane, to graphs of equations. So a relationship between two quantities, x and y, can be expressed as an equation in two variables. So something like y equals 4 minus x squared. We have an x, we have a y in there, so that is an equation with the equal sign. And a solution of the equation with these two variables is going to be an ordered pair, x comma y, such that when the x coordinate is substituted in for x and the y coordinate is substituted in for y, we end up getting a true statement out. So for example, let's show that the ordered pair 3, comma negative 5 is one solution for the equation y equals 4 minus x squared. So 3, comma negative 5, this is x comma y. So we're going to plug a 3 into x, negative 5 into y. So y equals 4 minus x squared. So plugging in negative 5 for y, that's negative 5 equals 4 minus plugging in a 3 into x. So we get negative 5 equals 4 minus 9. So negative 5 equals negative 5. So that's true, so that is a solution. The graph of an equation now in these two variables x, y is going to be the set of all of these x, y coordinates where these coordinates satisfy the equation. So one way to actually graph equations, which we're not always going to be doing it this way, but one way that is going to work for now is going to be by plotting points. So let's graph y equals 4 minus x squared by selecting integers for x, starting with -3 and ending with +3. So that just means we're going to be using the x values -3, -2, -1, 0, 1, 2, and 3. So we're going to be using those x values. We're going to plug them into the equation, into x. We're going to find the corresponding y value, and that's going to give us an xy coordinate. So plugging in -3, that's going to give us 4 minus -3 squared, which is -5. It's 4 minus 9. So that gives us the xy coordinate -3, -5. Next, we plug in a -2, 4 minus -2 squared. That's 4 minus 4, so that's a 0. That gives us the coordinate -2, 0. Plugging in a -1, 4 minus -1 squared, that's 4 minus 1, so that's 3. Coordinate -1, 3, and I'll just fill out the rest of these. So we have all of these x, y coordinates now. So what I'm going to do is just going to plot these as points. So -3, -5 would be right here. -2, 0 would be right here. -1, 3 up here. 0, 4, 1, 3, 2, 0, and 3, -5. So we have this. We have these points all plotted. So we're going to connect these points now with a smooth curve. So smooth curve meaning rounded. So it's going to look something like this. And then put arrows on the end saying that it's going to keep on going in that direction. So this is y equals 4 minus x squared. Okay, so it's technically there's an infinite number of points that could be plotted on here. We just plotted several of them and then used them to connected them to finish the graph for that equation. So let's do another one. So we have, let's graph y equals the absolute value of x by selecting integers for x, -3 to 3. So once again, we're using -3, -2, -1, 0, 1, 2, and 3. So let's find all of their corresponding y values and have an xy coordinate for each one. So for the first one, the absolute value of -3 is +3. That gives us the xy coordinate -3, 3. Next, we have -2. The absolute value of -2 is 2. So that's -2, 2. Absolute value of -1 is 1. That's -1, 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. So plotting or writing these as xy coordinates, we get all of these. So now we're going to plot all of these points and see what we get. So -3, 3 is up here, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And then connecting these, we end up getting this. So this is y equals the absolute value of x. So you can see that this one was more linear. The other one was kind of, we had a rounded curve. So the previous one that we did, I'm just going to scroll back up here real quick. This is something called the quadratic equation. The shape of this is a parabola. This turning point is called a vertex. For down here though, we might notice that it's more of a sharp turn. So right there, this is actually called a cusp. So the other one was rounded, it's a vertex. This one is a sharp turn, that is a cusp. Okay, so for the next thing, we'll take a look at the intercept. So starting with the X-Intercept. The X-Intercept of a graph is going to be the X-coordinate of a point where the graph intersects the X-axis. So for the X-Intercept, the Y-coordinate is 0. So as an ordered pair, that would be x, 0, whatever the X-Intercept is, 0. So let's take a look at the x-intercepts for the one that we did a few pages ago for y equals 4 minus x squared. So when we graphed it, it looked something like this. So the x-intercepts are going to be where it crosses the x-axis. That's going to be right here and right here. So that means the x-intercepts are going to be x equals -2 and x equals +2. Or you can write them as an ordered pair. That's -2, 0 and 2, 0. Let's take a look at the y-intercepts now. So the y-intercept of a graph is going to be the y-coordinate of a point where the graph intersects the y-axis. So that means the x-coordinate is 0. So if the x-coordinate is 0 as an ordered pair, it would look something like 0, y, where the y is just the y-intercept. So once again, taking a look at the graph of y equals 4 minus x squared, looks something like this. So the y-intercept where it crosses the y-axis, that would be right there. The y-intercept is going to be 0, 4. Okay, so let's do one more page here with some examples for determining the x and y-intercepts to make sure we're good with it. So for the first one, we have this linear equation, which we'll actually get into graphing linear equations later on. So it's a straight line. So we want to know the x-intercept and the y-intercept. So for the x-intercept, that's going to be right down here. So it looks like, assuming it's crossing at an integer here, we're going to say the x-intercept is the coordinate -3, 0. It's crossing it at -3. And for the y-intercept, so seeing where it crosses the y-axis, that looks like it's crossing right here at 3. So that's going to be the coordinate 0, 3. Okay, and then for this next one, once again, this is looks like a parabola, which is what we graphed with y equals 4 minus x squared. So let's take a look at the x-intercepts. The x-intercepts are going to be, looks like right here and right here. So it looks like it crosses at x equals 0 and x equals 4. That's going to give us 0, 0 and 4, 0 for the x-intercepts. The y-intercept, it crosses, once again, that's at the origin still. That's the y-intercept also. So that's going to be 0, 0. So the origin, if it's crossing at the origin, that's going to be an x-intercept and a y-intercept. Okay, so that is it for section 1.1.